My name is Mark Lauder. I'm the Sales and Marketing Manager for Shindawa Generators, and this is our presentation of the DK180F paralleling demo. Let's start the presentation with a single unit operation. Let's turn on the controller. As we power it up, we'll notice we're in the single unit operation as opposed to the paralleling operation. Controller is powering up. We'll go ahead and start the machine. Notice the glow plugs just came on. Contactor just closed. You have 180 kVA of three-phase load available, 108 kVA of single-phase load available, or a combination thereof. You'll notice you're at 1800 RPMs. It's your load bank system. It needs to be in the auto position on single unit operation. Let's go through the controller features. You'll notice it had all of your readings. You'll see that you got leg to leg. You'll see that you have your voltage, which is at 208 volts, 60 hertz on your frequency, 1800 RPMs. As we scroll through all the different metering functions that we have, you have your coolant temperature, which is at 136, 118 on your PSI of your oil pressure. You got your battery voltage, your fuel temperature, your intake, your fuel rate, fuel injectors, and power factor. This gives you an idea of your internal DEF tank as well as your fuel tank. Notice you got 59 gallons on your internal fuel tank of fuel. Your DEF tank is at 15%. This would be your external tank. So if you're on your three-way valves and you have an external tank, we can monitor that tank as well. This is your synchro switch. If we're in the parallel mode, as the generators close into one another, you'll notice that this will angle in and close into the right synchronous bus. You'll notice that this is Gen 1, Priority 1. This is a servicing time meter, so you'll notice you have your servicing meters that will count down as you add hours. So right now you have 500 hours until your next air filter service, as well as your oil filter and coolant. It also tells you what your DEF filter is timed at. This is your three-phase voltage adjustment switch. So if I wanted to lower the voltage, I could do so here. And you'll notice that we just went from 208 volts to 205. I want to raise the voltage. And now you're back at 208 volts. Go ahead and shut the machine down. We'll hit the stop switch. Notice the contactor just opened back up. You're on a time delay to cool at this point. If you want to bypass that time delay, you hit the stop again. That's the basic functionality of the single unit operation, where you'll have simul-phase available to you as well. So you'll have three-phase, single-phase, and a combination thereof. Let's begin the paralleling presentation. First, we're going to get the cable. This is a 3-pin connector. I'm going to go ahead and remove this bolt to access the panel. Remove the cannon plug cover. This unit is connected. We're going to move to the next side to access the cover. Take off the panel. Insert the cannon plug. Engine number 2 is connected. Let's go ahead and start the paralleling version. You'll notice that we're in single unit operation. We're going to rotate this to parallel. As we power up the switch, your controller's going to come up. When we start this machine, because we are in parallel and simul-phase is not available in parallel, the single-phase breaker will trip. I'm going to go ahead and start the machine. Notice the breaker tripped. We have 180 kVA of 3-phase load that's available. As I rotate through the screens, this is your sync screen. You'll notice that we have this set as gen priority number 1. That's located here in the first digit. Let's go ahead and start the other machine. Coming up to the machine, we're going to do the same as we did with the previous. You'll notice you're in single unit operation. We're going to put it in parallel operation. I'm going to rotate the switch to power the controller on. Same as before, when the machine starts, it's going to trip the single phase breaker because simul-phase is not available during parallel operation. We're going to go ahead and start the machine. You'll notice the breaker tripped. We're at 1800 RPMs. We have 180 kVA of 3-phase load available. Go to our sync screen. And from here, we're going to go ahead and close the breaker. You notice the contactor just closed, so this side is closed. We have to now go to Gen 1, and on Gen 1, we're going to make them parallel with one another. Let's go ahead and close the bus on Gen 1. The units are now in parallel. We're going to go ahead and load the machines. For this portion, we're going to use a Abtron 500 kW load bank, and we're going to apply 100 kW of load to start with. Let's go ahead and start it up. Turn the fan on. You'll notice that we have 129 kVA of remaining load available. We're running at about 65 amps per leg. Now we're going to go over to gen number 2. Gen number 2 has 129 kVA remaining, and we're running about 65 amps per leg. We're going to go ahead and add 50 kW of load, and you'll see where they share the load amongst each other. Both machines are now sharing that 50 kW. You'll notice we have 109 kVA of load remaining, and they're now sharing the 50 kW of load. Thank you for joining us today for the presentation of the DK180F paralleling machines.